find the general solution of the given system. So you are given a system which is written in a standard form of vector x prime. Okay, so first find a minus lambda I. What is A? Let's call this matrix is matrix A, and then subtract it with lambda I. That gives you this matrix. Then find the determinant of it. So I'm gonna go across the row. So I have 1 minus lambda cover this column, this row. 1 times 1 minus lambda times 1 minus lambda minus 0. Okay, and then minus 0 plus 1 cover this column, this row. So 0 minus 1 minus lambda. Okay, and then distribute this out, simplify it. So you will get this, set this equal to 0, and then solve for lambda. You will get lambda equals 1, 0, 2. So here's your eigenvalues, and with each eigenvalue you will get an eigenvector for it. Let's find out what those are. So let's take a look at the first case where lambda equals 1. Plug it into here. That gives you this matrix augmented with 0. Okay, normally you would reduce it down to base matrix, but in this case you almost get to it, right? So very quickly I see that k1 equals 0, k3 equals 0, and k2 is everything. So let's choose k2 equals 1. You can choose whatever value for k2 because it's everything, but do not choose 0 because it's gonna give you a new vector, right? Then vector k1 is equal to 0, 1, 0. Now you are going to repeat this process for lambda equals 0. Plug it into this matrix. That gives you a new matrix, which is this, augmented with 0. Right, now that's very quickly I can figure out k2 equals 0. Right, now use the first one, either the first or the third one. k1 plus k3 equals 0. Then k1 equals negative k3. Choose k3 equals 1. Then that gives me k1 equals negative 1. You can choose whatever value for k3 as long as it's not 0. Then that my vector k2 is negative 1, 0, 1. Now you are going to do this process one more time for lambda equal 2. So my third matrix is this one, augmented with 0. Alright, now again it's similar to this one, so I can see that negative k2 equals 0. Then I found out that k2 equals 0. Now use the first equation. You can use the third one, it's up to you. Negative k1 plus k3 equals 0. Then k1 equals k3. Use k1 equals 1. Then 1 is the value for k3. Then vector k3 is 1, 0, 1. Now let's go to the final step, which is the most important step here, which is writing your final answer. Because you have 3 distinct real eigenvalues, your final solution will be written in this form. Vector x equals c1 times k1. k1 is this one, and then e to the lambda 1t. lambda 1 is 1, so you have e to the t plus c2. k2 is this, e to the lambda 2t. lambda 2 is 0, so you have e to the 0t, which is 1 if you simplify it, plus c3. k3 is this, e to the lambda 3t. lambda 3 is 2, so you have e to the 2t. Alright, so here is your final answer eventually. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.